Welcome to part one of my series on Pester in action. This is a series I presented to a user group just this last week, and I got really great feedback on it. So I kind of wanted to do the full thing uh, for you here. So I'm going to just kind of jump right into it, and I'm just going to go from there. All right, so Pester in action. My goal with this series is to share with you how I use Pester more in my environment and tricks I've kind of learned along the way. But to get there, I'm going to start with a crash course in Pester so that you at least are familiar with what you're seeing when we get into more of the code examples. Pester itself is a unit testing framework. Um, I think the intent is to test code, but anything you need to test, Pester can do that for you. And that makes it sound more complicated than it is. When I say it's a unit testing framework, it's just a way to assert that your code does what you say it does, or what you think it does. You basically say, hey, at this point, I know this is true. This is a fact. It'll always be this way. And you just add a Pester test to assert that that's true. That way, when the laws of physics are broken, um, for whatever reason, these things are failing, they can help you find back your root cause and what's actually broken. There's whole theories on like test-driven development where they say write tests before you write your code. I'm not going to go into that, but there's definitely a community and aspect around test-driven development that um, many people find quite interesting. So let me get our demo up. Before I dive in too deep, I do want to say that all of these scripts and our examples are up on GitHub. So you want to download these and run through these on your own or with future videos, feel free to do that. So I'm going to pull up my ISE, and I've got my first example here. So a lot of this material here I pulled off Pester's wiki. They've got great examples up there. I encourage you, if you want to learn more about actually how to use Pester, that is a great reference. So what we're looking at right in front of us is a very simple Pester test. It's got a couple new keywords and commands that it adds into PowerShell. So we have our describe sections, and our it sections are ways to organize and group your tests. You're saying this thing that you're going to test, it does this. So maybe if I didn't say test value, but say it has the value. That might be a better description to put in there, right? So my generic test has the value, actual value. And the commands should be as a way to actually test and assert the script or the code that you want checked. So this is a pattern you'll see over and over. You describe something and you say it has the value, right? And a lot of these commands, you have multiple of them here in the code block. And I could say should not be actual value 3. Does not have the value actual value 3. So I still have, so I just added a second test. I get my own it block, and with the should command, I'm saying, hey, this value should not be this. And because I'm doing the negative here, this will pass because it does not match actual value 3. It actually matches actual value. So I can interactively run these this way. And this is what my test results look like. Is it has the value actual value and does not have actual value 3. So if we want to see a failed test, right? If I say it should be actual value 3, it does have the value, and I run this again, it's going to fail and complain that, God, that red's kind of hard to read. But my first test passed, but my second test, it's saying that the string differs at, I expected actual value 3, but it was actual value. So it packages up the reporting of things, and it tells you what it should be and what it is. So it's quicker to diagnose what your problems are. I mean, this is all code you could write on your own in PowerShell to do these things, but this module makes it easy because in just this simple line here, I mean, we've really added the reporting and the testing, and it handles errors and exceptions just beautifully because it's scoping things and packaging things in a way that makes it easy to test. So let's clean up my example here. And I want to go in to show you some of the should tests, right? And that's a lot of the magic is. You know, this should be, well, they got lots of should commands. So let me pull up my should scripts here, and I'm going to increase my screen a little bit here. So this is the one we just saw, right? It should be is a way to take an actual value and say, this thing, we're going to pass it over the pipe to should be this value. I have several commented out here that are so I have several that are commented out that are failing tests, and I left those commented out for these scripts because I want my whole thing to pass to give me green results, but also to show the syntax of something that would fail. And because of the word not in here, this test would fail because it's not a match. As I go down the list, sorry, to go down the list, the thing with the value up here is it's not case sensitive. Should be is not case sensitive, but should be exactly is. So if we need something to be exactly what we expect it to be, the exactly does that. And I think before I dive in too deep, I do have highlighted up here the web page that goes into the should operator. And I could probably just do my demo off of that, but since I have these already over my other code, I'll continue down that path. That's how I did the demo the other day. You know, I didn't know I'd be online or if I'd have internet connectivity. So we'll just run the scripts. Should exist, right? This is a fancy way of saying test path. Does this path exist? Should exist, see Windows? Yeah, that should pass. I'm going to collapse these as we go here. Should contain. So this takes a file and it tests it for a regex pattern, actually. So in this test, first thing I do is I create a file, and I give it the value, I am a file. Don't worry about this test drive at the moment. I will come back and describe what that's doing. But it's basically, yeah, it's a temporary place to put things. So here I'm saying this file should contain I am. It'll pass because it's not case sensitive and that's in the string. Test drive should contain, I should start at the beginning of the line with an I and any character at all, but it should end in files, and this is the end of the line. And this pattern matches that well, so that will also pass. If you go down there, should contain exactly is case sensitive in what it's testing for within a file. Should match. And I'm back to values, right? This value, strings specifically, should match, and just like your match keyword, over the line. And I got should match and, as expected, should match exactly to make sure your cases are exactly what you wanted. Should throw is a very interesting one in that this lets you take code that you expect to throw errors in conditions in certain ways and prove that they actually do throw those errors. So here's an example where I'm calling some imaginary function that just does not exist. I've not defined foo, so this guy is going to throw an error. I can actually call foo command line, and I can actually get an error, and here it says, hey, I have no idea what that is. Sorry, my error messages are green here. It's like foo is not recognized as the name of command line, right? Since it says should throw, it catches that condition and actually passes this test. So I can throw errors and exceptions and not hose my whole test suite because I've got it contained. Catch is I do have to put it into a script block like this, or else it won't catch the error and handle it properly. If I have valid PowerShell code in there, like here I'm assigning to a variable, it should not throw because I know this is valid. I can look at it, I can see it's valid. I expect it to not throw. If you need to throw a specific error, like if you throw something upstream, you can actually test for that exception. So if I throw this message, I can catch this message and pass the test because of it. Should be null or empty, or should not be null or empty. I use this actually quite a bit. This is probably one of my go-to should statements. Like I'm pulling results from an object, querying AD or whatever I'm pulling. I'll be testing against null or empty all the time. And so in this, I'm tossing null over to should be null or empty, all one word. And it's the null condition test. So that's all of my should examples. I said they're the same ones from the website. In fact, a lot of the text is the same, and there's a lot more tips along the way on the wiki. So if you're interested in understanding these should commands better, I would definitely go to the wiki and read up on it. I'm not going to save that. And if I invoke Pester, on my should statements, they should all pass. So here's what several should conditions look like. Yeah. Because I use the invoke pester command to execute the tests, they do add additional depth to what's being tested. I've got my overall time, how many pass, failed, skipped, and pending are special keywords you can use later. I'm not going to get into those so much, but knowing how many pass or failed is valuable. If you're using a continuous integration or a build environment, Pester can enable an exit code. So it basically returns a value to your process telling it how many things failed. And there's also output that, I don't know where it is in here, but you can output things to XML and objects to actually walk the tree of tests. And I want to get into a couple more tests here, or a couple more features of Pester before we move on. And the next keyword I want to introduce to you is context, right? It's really just another level of organization of your tests. So you have describe, context, it. I got these 3 levels. It's almost like it's another folder. So if I take this block of code and I run it, the context is just this second level indentation here. So where this is the context, as the tests get larger and more in depth, having just that way to group them is quite nice. In fact, while I'm doing these tests, let me kick off some from my environment. So this is going to take a while to run. And I'm just going to let these kind of chew through, and I'll loop back to them at the end to kind of show you what a larger test run of Pester tests might look like. The test drive. So we saw it earlier. It's really just a temporary place for files and folders, or a temporary place for files to use in your tests. The value of this is you want a workplace that is cleared up and cleared out, cleared up between sessions. Because you don't want to create a file in one test and find the file on pass, and then later have the tests find the file you created the first time you ran the test. Because you might break the feature that's creating the file, but since you got a working directory that's not unique to that test, you're not going to find it. So the test drive is a location, actually it's in your temporary folder, but it creates a new one for each describe block. I think if you define something outside of the describe, it can be seen inside a context, but it might be the case. I have to verify this, but I was thinking like within the context, there's some scoping there that if something's created there, the next files might not, or the next context might not see those files. So here's what I'm really just saying: setting the path to the test drive, creating a file, and I'm proving that the file exists. Can I use the test drive? Yes. Perfect. Passes. It's green. We're good to go. The next one, and this is a great one for script and module testing, is the mock keyword. This lets you substitute one function with another function for the purposes of testing your stuff with either standard values or an environment where those other functions don't behave the same way. The example I have here is the date function, right? If you're running tests that are dependent on certain dates into your code, getDate is going to tell you the current time every single time. So every time you run it, you might actually get different results based off of the value from this function. So in this example, I mock the getDate with a return date time of January 2nd, and every time my code calls getDate, it will always get January 2nd, 2014. So it's a way to test my stuff instead of, I'm not testing getDate, I'm testing my things, and it depends on getDate. I had another set of scripts where I was doing stuff with Seuss, which in that environment, it's only going to work on the Seuss server, these scripts, but I needed to validate my code on a different box, or my local box, or offline when Seuss wasn't available. So I wasn't like testing Seuss, I was testing my stuff. So I would mock the Seuss commands to return back specific things I wanted my code to see to help validate it. Another good trick is you actually throw errors to these mocks too. So if you want to make sure your code is handling those error conditions on things that don't throw errors very often, or in unusual circumstances, like I don't know what off the top of my head, but another detail is you can see how often your fake function was called. So you can say, hey, I did this one thing. I know I only called getDate twice, or I'm pretty sure I only called it twice. And this thing here asserts that, yes, this was only called twice. This might not be the best example for it, but maybe a good one would be a database connection to verify your code is only opening one connection when you think it's only opening one connection. This is a great way to track those issues down, where if you're expecting it to execute at once, but it's coming back at once per row or something to that effect, this can give you tests that can catch things like that. So let me go back and execute my other feature tests. And here is all of those running, which are a nice grouping of them, but they all passed. So let me hop over and see how my large suite is doing. And look at this. I've got 948 that have passed, none failed. So this is my module in my dev environment that looks like, at a glance, I've got a ton of tests in here. And you can see how having different contexts and described sections groups them together a little bit better. So I'm going to wrap this video up here. The next video, I'm going to actually take a basic script and wrap Pester around it and make our whole process more advanced along the way. So, yep, so I'll see you in the next video. Next video should be part 2.